Hello guys, welcome to my channel. In this lesson, I am going to show you how to rationalize denominators of radical expressions in order to simplify them. Okay, so let's go ahead and look at one example. So for example, if you have a problem like this one that has a square root of 2 over 5, in order to have the simplified form of this expression, the denominator has to be free of the radical sign. This is because this expression is the same as square root of 2 divided by square root of 5. Now you can see that the denominator here has a radical sign, and you do not want that. So this number here is irrational. The square root of 5 is irrational. So if you plug this in your calculator, it gives you decimals that do not repeat and do not have patterns. Okay, so now in order to make the square root of 5 become rational, the trick is to actually multiply the denominator by square root of 5 and the numerator by square root of 5. So what I mean is I'm going to introduce square root of 5 and square root of 5 to the numerator and the denominator, and then you multiply them. This is what you call the process of rationalization. Okay, so when you're doing this, you're trying to rationalize that. So now square root of 2 times 5 would go to square root of 10. This is allowed, and then you have square root of 5 from square root of 5 is square root of 25. So therefore, you get square root of 10 divided by the square root of 25. We found out that that would be 5. And here you're using principal square roots. All right, so here you cannot divide 10 by 5, so you just leave your answer like that. And what I notice here is that this is now a rational number 5. All right, you can see. So that's why you say you're rationalizing when you carry out this process. So when you multiply a rational number to itself, the radical sign always goes away. So this trick will help you simplify rational expressions and quotient form. All right, let's do another example here. Number 2, let's see where we have 1 over the third root of x. Okay, so since we have that, what we can do here is to rationalize very quickly by multiplying by the third root of x, okay, numerator and denominator. And once you do this, the radical sign goes away and it just leaves you with what? X. And then we can multiply the numerator and that will just be cube root of x. This is what you're looking for. So the denominator is now free of the radical sign. So this is how you quickly do that. And let's take another one. Let's look at the fifth root of x to the third power divided by y to the fourth power. Okay, now to simplify this result, we'll just separate the radical signs. So the fifth root of x to the third divided by the fifth root of y to the fourth. Okay, so what we get here will be just rationalize by multiplying the numerator and the denominator by the fifth root of y to the fourth power. Okay, this is what I'm going to do here. I'm going to introduce the quantity that I need to rationalize. So I'm just multiplying the numerator and the denominator by the denominator so that I can rationalize that. So when I multiply, so the radical sign will go away. You get y to the fourth power. And then if you look at the top now, you're going to get x to the third power multiplied by y to the fourth power. So both of them will go in the same radical sign because they have the same operator on them. So fifth, and you have x to the third, y to the fourth. So this is how you can leave that. Let's try more problems. Let's try 4. Okay, number 4, we have 2 over the cube root of 2. To do this, I am going to rationalize by multiplying both the numerator and denominator by cube root of 2. So cube root of 2 cube root of 2. Now, to do this, when I multiply, the denominator becomes free of the radical sign, but the numerator will be 2 cube root of 2. All right, so from here, I am going to be able to look at what I'm dealing with here. I think I can actually divide 2 and 2. Okay, I get 1 and 1. All right, which is my final result would be the cube root of 2. This is how you simplify to that. All right, let's do the final example. Example 5, or number 5, which is 1 over square root of 3. Again, you just rationalize by multiplying by square root of 3. And then you have 1 here. Now 1 times square root of 3 will exactly give square root of 3. And then you have square root of 3 times square root of 3, which will always go back to the rational number, which is 3. So that means this will be your final result. I hope this video is helpful, and I will see you in the next video.